not the end. In fact, END is effort never dies. And if you get no in an answer, then remember, no is next opportunity. So, always be positive. Hi learners, welcome to the video. I am Taranjeet from First in Class. I hope that your studies are going well. Well, in the previous video, we have learnt about adding, subtracting and multiplying using a number line. So, do you remember that in our last video, we had swapped the numbers in the last calculation and we were checking if we get the same result? Well, don't worry. We are going to explore the answers to these questions and also learn about some other properties of whole numbers, namely the closure property, commutative property and the associative property. So far, we have learnt about whole numbers. Now let us recall what they are. Yes, if we include 0 with the natural numbers 1, 2, 3, 4 and so on, we get the set of whole numbers. Now here, we have taken the first 10 whole numbers. We are randomly adding, subtracting, multiplying and dividing the numbers. Will we always get a whole number on adding two whole numbers? Now let us give it a try by adding any two whole numbers, say 7 add 2, 3 add 5 and 0 add 4 is 4. Great job! 7 add 2 is 9, which is a whole number. 3 add 5 is 8, which is a whole number. And 0 add 4 is 4, which is also a whole number. We always get a whole number when we add two whole numbers. Thus, we conclude that whole numbers are closed under addition. Now, let us check the case in subtraction. Will we always get a whole number when we subtract two whole numbers? Let us take the example of 7 and 5. Is 7 minus 5 a whole number? Indeed, it is. 7 minus 5 is equal to 2, which is a whole number. Now, in this example, the first number is greater than the second number. Now, let us take an example where the first number is lower than the second. Pause this video and give it a try. Now, did you get a whole number in this case? Well, good try. As you can see that 3 minus 4 is not a whole number and 0 minus 2 is not a whole number. Well, we can conclude that we don't get a whole number when we subtract a higher number from a lower number. Thus, we can say that whole numbers are not closed under subtraction. Now, let us move forward and check the closure property for multiplication. Will you always get a whole number when you multiply two whole numbers? Try and think of some examples. As you can see here, 5 multiplied by 2 is 10, which is a whole number. Similarly, 3 multiplied by 4 is 12, which is a whole number as well. Yes, learners, we always get a whole number on multiplying two whole numbers. So, whole numbers are closed under multiplication. Now, can you check the closure property for division? Let us check these calculations 4 divided by 2 and 6 divided by 5 to find out. Well done! 4 divided by 2 is 2, which is again a whole number. But do we get a whole number when we divide 6 by 5? No, we don't. We get a fraction and not a whole number when we divide 6 by 5. So, we always don't get a whole number when we divide two whole numbers. Hence, whole numbers are not closed under division. Hence, we conclude that whole numbers are closed under addition and multiplication only. Now, let us move the discussion forward to commutative property. Well, I am sure you like chocolate smoothie, isn't it? Yum! Would you like to learn how to prepare it? Well, if you look at this recipe, we can add whole milk and chocolate syrup in the softened ice cream in an order. You can add milk first and then chocolate syrup, or chocolate syrup first and then milk. The result would be the same. Similarly, in mathematics, we have the concept of commutativity. So we say that whole numbers are commutative under an operation if we get the same result on swapping the numbers. Now try swapping the numbers in the calculations shown, and that would give you a hint to see that which operations are commutative for whole numbers. Now pause this video to try the calculations. In case of addition, 8 add 4 is 12, and so is 4 add 8. But do we get the same result when we swap the numbers in subtraction? As you can see here, 5 minus 13 is not a whole number, and 13 minus 5 is 8, which is a whole number. So, the order of numbers does matter in subtraction. Moving forwards to multiplication, 5 multiplied by 3 is 15. On swapping the numbers, we get 3 multiplied by 5, which is also 15. So, the order of the numbers does not matter in addition and multiplication. Now, can you check if commutativity holds true for division? Let us check the calculations 8 divided by 4 and 4 divided by 8 to find it out. Now, 8 divided by 4 is 2 and 4 divided by 8 is a half. So, we get different answers when we swap the numbers in division. So, division is not at all commutative. So, we conclude that addition and multiplication are commutative for whole numbers. Next, we will be moving forward by taking 3 whole numbers and see in which operations the order of the numbers matter. Now, let us start with addition. Take 3 whole numbers 2, 4 and 7. In case 1, add 2 and 4 first and then add to the sum of 2 and 4, and in case 2, add 4 and 7 first and then add 2 to the sum of 4 and 7. Now pause this video and try it out. I must say that you have shown amazing efforts at adding the numbers. In case 1, 2 add 4 is 6, which when added to 7 gives us 13. In case 2, 4 add 7 is 11 and 2 add 11 is 13. So, we get the same result in both the cases. Now, can you think of adding these 3 numbers in another way? Also, do not forget to check the sum of the numbers. So, we conclude that addition is associative for whole numbers. Now, let us take the same numbers and check what happens in subtraction. In case 1, subtract 4 from 7 and then subtract 2 from the result obtained, and in case 2, subtract 2 from 4 and then subtract the result obtained from 7. In case 1, 7 minus 4 is 3 and 3 minus 2 gives us 1, whereas in case 2, 4 minus 2 is 2 and 7 minus 2 gives us 5. The results in both the cases are different, of course. So, order of the numbers does matter in subtraction. Now, can you check the case in multiplication taking the same numbers? In case 1, multiply 2 by 4 first and then multiply the product obtained by 7, and in case 2, multiply 4 by 7 first and then multiply the product obtained by 2. Now in case 1, 2 multiplied by 4 is 8, which when multiplied by 7 gives us 56. Now let us understand case 2. 4 multiplied by 7 is 28, which when multiplied by 2 gives 56 as the product. Well, you can observe that the product is the same in both the cases. So, multiplication is associative for whole numbers. Now let us check the case in division. Here are the 2 cases given to you. In case 1, we are dividing 48 by 12 and then the quotient obtained by 4. And in case 2, we are dividing 12 by 4 and then 48 by the quotient of 12 and 4. Come on learners, try it out. Now in case 1, 48 divided by 12 is 4, which when divided by 4 gives 1. Now in case 2, 12 divided by 4 is 3. Now when we divide 48 by 3, we get 60. We observe that the results in both the cases aren't same. So division is not associative. So we conclude that associative property holds true only for addition and multiplication. So learners, I hope that you are now confident with the various properties of whole numbers. First, the closure property, which states that the whole numbers are closed under addition and multiplication. Second, the commutative property, which states that addition and multiplication are commutative for whole numbers. And the third, the associative property, which holds true only for addition and multiplication. Now, let us try a question to understand how well we have understood the topic. Now, can you simplify 250 multiplied by 137 multiplied by 4 using suitable rearrangement? So, learners, can you now think of a magic number which when multiplied by any of the whole number results in 0? So, stay tuned for our next video to explore this question and learn about the distributive property, division by 0 and identity. So, see you in the next video. Take care and keep smiling. Have a great day.